Okay, hi guys. We're going to be continuing with the study of inverse functions. This is part 2. And before we proceed to looking at this question, right, find the inverse function of x minus 3 squared plus 2 for a domain of x is less than 3. We're going to look again at the issue of domain and range. Okay, so let's review what an inverse function is. An inverse function it takes the outputs of an original function, f of x, as inputs, and it returns back as outputs the inputs of the original function, right? So if you imagine you've got a function f of x that takes inputs and gives you outputs y, what does the inverse function do? It takes those outputs as inputs and returns back as outputs the original inputs to your function, right? So that is what an inverse function does. It takes you back to your inputs from your outputs. Now, if that's the case, then we also thought about the idea of domain and range, right? Because the domain of the original function f of x is the set of all input values to f of x. And the range of the original function f of x is the same as the set of all values of the output function for f of x. But then what we said is, well, if the outputs of f of x become the inputs for the inverse function, then what we should expect is that the domain of the inverse function should be the same as the range of the original function. In other words, we expect that these two things here should be the same, right? The range of the original function should be the domain of the inverse function. And likewise, if the inverse function gives us out these values, and we've got the range of the inverse function there, so that's the range of the inverse function, the set of all possible output values, then what we should expect is that those will correspond to the domain of the original function, right? Because the whole point of the inverse function is that its outputs should correspond to the original inputs. Okay, so to clarify, for an inverse function, the domain of an inverse function is the same as the range of the original function, and the range of the inverse function should be the same as the domain of the original function, right? So range and domain basically switch. So now let's have a look at our problem. We've got a function here, f of x is equal to x minus 3 squared plus 2, with a given domain of x must be less than or equal to 3. Now, before I even try to calculate the inverse function here, what I'm first going to do is I'm going to try to sketch this function, right? So we want to sketch the function y is equal to x minus 3 squared plus 2. I'll rearrange that a little bit. So we're going to get y minus 2 is equal to x minus 3 squared. And hopefully what you remember from your shifting and scaling stuff is that this is basically the same as the graph of y equals x squared, but we've replaced x with x minus 3. And so that is a shift right by 3. And we've replaced y with y minus 2. And so that is a shift up by 2. Okay, so if I was to draw that quadratic, what's it going to look like? Quadratic is going to look like original quadratic y equals x squared is this, like that. But we're going to shift that to the right by 2. So 1, 2. I'm going to shift, sorry, not shift it to right by 2, shift it to right by 3. And we're going to shift it up by 2. So 1, 2. Right, so our new function should look like that. Okay, so we've taken the old one, shifted it to the right by 3, shifted it up by 2. So that's what we get. Now, let's just think about our range and domain, because the domain is given for us here, right? The domain there is x is less than 3. So we're only interested in these values here, right? For the values where x is less than 3. So what we've actually got to do is we've got to get rid of this side of the graph because we're not interested in that. So let's do that. Let's just get rid of that. Gone. Redraw. We're interested in that thing there. Okay. Now, what's the range of that particular graph? What's the range of f of x? Well, it's everything that is greater than 2. You see that? There we go. So now we can write this. So the domain of f of x is x is less than or equal to 3. And the range of f of x is that y is greater than or equal to 2. Now, why is that important? It's important because if you remember rightly, what I just said a moment ago is that the domain of the inverse function could be the same as the range of the original function, right? So in other words, if the range of the original function is y is greater than 2, the domain of our inverse function should be x is greater than or equal to 2, right? Because the range becomes the domain. And in the same way, the range of the inverse function, we expect should be the same as the domain of our original function. So we expect that y in this case should be less than or equal to 3. So what I'm trying to tell you is the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. Right? So if I was to sketch this on another graph, right? If I was to take this idea, then what I'm expecting is draw a graph like this. Right, so this is going to be for my inverse function. Okay, so 1, 2, 3, 1, 2, 3. Right, I expect that. I expect that the domain of my inverse function is everything that is greater than or equal to 2. So let's sketch that on. I want the domain of my inverse function to be everything that is greater than or equal to 2. Okay? And similarly, what I want is I want the range of my inverse function to be everything that is less than 3. So let's sketch that on. I want the range of my inverse function to be everything that's less than 3. Okay? So even before I know what my inverse function is, right? Before I even calculate it, I know what the range and the domain should be. So that gives me an idea of what my graph is going to look like. So having said that, let's now try to calculate. So y is equal to x minus 3 squared plus 2. We rearrange this, we're going to get y minus 2 is equal to x minus 3 squared. We're going to square root both sides, but when we square root, we've got to bear in mind that we've got a positive and a negative value. So this becomes either plus or minus the square root of y minus 2, okay? I'm going to explain why that is in a second. Okay? And so lastly, if I rearrange, I'm going to get that x is equal to plus or minus the square root of y minus 2 plus 3. Okay? And so my inverse function, f inverse, is I just then replace the y with x. So it's plus or minus the square root of x minus 2 plus 3. So this thing here, that is my inverse function. Now then, if we think about sketching this, this is going to look like a square root, right? It's going to be the square root of x, something like that. We need to think how it's been shifted. This square root has been shifted to the right by 2, and it's been shifted up by 3, right? So it's been shifted to the right by 2 and up by 3. Okay, so, all right, we just go there. So we expect this graph here to be shifted to the right by 2 and up by 3, like that. But hang on, that doesn't look quite right, does it? Because this graph, the range is not something that's less than 3. Yeah? In fact, it's the opposite. It's something that's greater than 3. So why is that? Well, because what we've got here is not the positive square root of x minus 2, but rather its reflection, the negative of that, right? Because what we should get is not this thing here, but if I draw it in blue, you get that thing there, right? Because when we take the positive square root value, what we end up with is we end up with a range that isn't right, okay? Because it's greater than 3. So we've got to take the negative value because that gives us the correct values of the range, which will be less than 3. So in this particular case, you actually know that f inverse of x is not plus or minus, it is minus the square root of x minus 2 plus 3. So that is actually the inverse function there. Okay? So that seems really very complicated. Now, may I make a suggestion for those of you who are trying to solve questions like this? Typically, what I notice students doing is that they do all of this stuff first, right? In other words, they try to calculate what the inverse function is. So they do their rearranging and make x the subject and so on. And then what they do is they get to this bit here, right, with the plus or minus square root, and they either forget about it or they just guess it's plus or minus, right? It's a 50-50 chance. I think that's the wrong way of looking at it. The right way of looking at it is actually to start by thinking about domain and range at the beginning, right? Don't think about domain and range at the end. Think about it at the beginning. So consider your original function, right? Whatever this is, and ask yourself the question, what is the domain and range of that? Because if you can get the domain and range of that, then you actually know what will be the domain and range of your inverse function. Right? Because the domain of the inverse is the range of the original. The range of the inverse is the domain of the original. So when you've got that, you already know where your graph has got to be for the inverse function. And so if you know that, then you should be able to tell yourself whether you're going to have a plus square root or a minus square root, right? Because you should be able to figure out that your values of your graph have got to lie within a certain range of values. Okay? All right, that is quite complicated. So good luck with doing those questions, but try to adhere to the principle that I've just given you. Right? Think about what the domain and the range is saying. I think that will really help you to do these problems. Okay, take care, guys. I will see you again next time.